Hey guys, we have here a homemade prototype of a brushless DC motor controller using 8MEGA164. I was curiously led to this. I've looked at some of the hobby motor controllers. They don't seem to have control via SPI ports or I2C. So I thought I'll make my own with these options. I've used 164 at Mega purely because it's got the extra port facilities available. So I'll just run you through some of the sections in the prototype for those who are working on making your own brushless DC motor controllers or are curious about learning in this area. So here you have the main chip, or the slave controller. Then you get 6 commutation outputs from there, IOs from there. I am driving the high side MOSFETs with PWM. The low sides are not being driven by the PWM, so the AND gate there handles the PWM driving for the high sides. Then I have the 3 high side low side drivers, the international rectifiers. I think it's 2101, so they're them. And then you have the standard, the 40 amp MOSFETs IRZ. I think I'm using the 34N here. Then you have also the analog feedbacks from the motors. You have the back EMF being fed to the ADC of the motor controller, so you can look at the back EMF and drive the commutation. I've only implemented at this time the UART section, control section, and the SPI control mechanism. So the slave controller is being driven by a master chip, which is the 32-bit Atmel's UC3A0512. The chip that you see next to it is the RTL Realtek Ethernet chip. I was working on implementing TCP/IP control in order to control the whole slave motor as well. I've so far managed to implement Modbus on this and the standard ping. You can also see the UART of the slave controller. It's the RS232, which I'm not using at the moment. It's just sitting there. So the whole slave controller is being controlled by the master chip. And the master chip is connected to the SDK board right at the back. And the SDK board, I've got it hooked up to the laptop, and I'll be controlling via the terminal. Serial terminal. So let's run through some of the commands. So it's a bit hard to focus here, but just bear with me. So okay, so I have various commands being fed to the or programmed into the slave controller. I have the anti-clockwise rotation, so I'll just type in A, and there it goes. The motor starts anti-clockwise. I've driven this motor up to about 80,000 RPM. That was with a 14.7456 megahertz crystal running the slave controller there. Interesting thing, I found that you can run the ADC to as low as, well, with a prescaler of 8 running at that sort of frequency. But if you up the frequency to about 18 megahertz, you can only run the ADC with a 16 prescaler, which slows the prescaler down a little bit. And I noticed if you ran the slave controller at that high frequency with 18 megahertz, you can only go up to about 70,000 RPM due to the fact that you have a slower ADC running, processing the back EMF. Anyways, at this time I will run it to a few thousand RPMs just so you can you get a feel for it. I have here, I will
run it up. So you can see the RPM feedbacks being displayed to the display. I can also report the current RPM, so there's your current RPM. They're about 12,000, and all this is of course coming from the master chip, and the master chip is getting the reports from the slave chip, and the control is being passed through SPI only. And you can see the SPI link straight from there to the slave. So I will lower it down, and I'm doing all this from my laptop keyboard, which is next to the screen, and then comes the stop command, so that stops the motor. And I'll start the A, anti-clockwise, up it again. I don't want to run it very high. You can see the motor's, moving from its position. It's very dangerous. If I don't hold on to it, it basically lifts off the table. So that's it for today. Thanks for watching. I will tell you that there was a lot of stuff to learn about brushless DC motor control during this project, and if you are planning to make your own, you should really read up about the subject before you delve into it.